Let's get started with the story of a pyramid. Now, we know that a pyramid is a 3D figure. We all are aware of the Great Pyramid of Giza and other pyramids that are in the world. We are interested in the mathematics of pyramids. We are interested in triangles. We are interested in the base of the pyramid. We are interested in the number of vertices of the pyramid, the number of faces of the pyramid, and all the calculations associated with it. So let's look at this diagram. Let me grab a marker and let me label this side over here. I'm labeling the sides of one of the faces. This is one side. This is the other side over here. And then this is the base of this triangle. So what I have labeled over here, that is one of the face of the triangle. Now let me focus on the base. This is one line. Let me make it thicker. So in green color, this is one of the sides of the base. It looks like a square base. So there are 4 sides to it. All the sides have equal length. So yes, there is a base of the triangle, of the pyramid. The face is a triangle and there are 4 such faces. That means I can apply sine, cosine, tangent if it's a trigonometry question, or I can apply Pythagoras theorem. And what else is there? Then we will be talking about the areas of all the surfaces. We will be talking about the volume. Now, if I'm interested in this particular face of the triangle, and if this is a square, that means this is an isosceles triangle. So let me label it. These 2 sides will be equal. And if I draw a line from this point all the way over here, I'm just talking about the face, that will be perpendicular line, and this would be divided equally also. And then I can have a perpendicular drawn from here all the way till here. Now let's look at the next diagram. This height over here, this is known as the slant height, and this one is known as the perpendicular height. So now let me label this thing in green color. That is over here. So I need a thick marker over here. And if I label it even more thicker than this, so therefore let me choose this, and something like this is better. So if I draw a line like this, this is the perpendicular height, and this one, the reddish one, that is the slant height over here. And then let me draw a purple line over here like this. So now this purple line, that is the base of this triangle. So this is the base, this is the height, and this is the slant height. Now let me give it some symbols. Let me use H for the height. Let me use B for the base. Let me use L for the slant height. Therefore, L square is equals to H square plus base square. That is one of the application that I'll be using it up later. And remember, this is a right angle triangle over here. So therefore, this is also right angle triangle. Now let's look at this diagram. If I look at this diagram, what I see is that this is the lateral face. Then this is the perpendicular height, which I have labeled over here in green color. Base is in purple color, and this slant height is in red color. So let me use the same colors over here. So therefore, let me choose this, and let me just reduce the thickness. So green is the perpendicular height that goes like this, and the base that is in purple color that goes like this, and the slant height is in red color. That goes like this. So another variation of the same figure. Just want to make sure that everything is crystal clear. So this goes like this. Now, there are two kinds of pyramid. This is a regular pyramid because the base has equal sides. And the other one, that's an irregular pyramid because of unequal lengths of the base. So, yes, they both are pyramid, but one is regular, the other one is irregular. And further detail of this is that there could be a scenario in which the highest point, that is the apex, and the center of the base over here, they are exactly aligned, something like this. So let me draw this line over here in green color. So that goes exactly like this. And let me make it still straighter. So that is like this. But in another scenario, the apex and the center, they are not aligned. The center is different and the vertical line is different. Now, if I talk about the formulas are very simple. First of all, let me talk about the surface area of a prism. Actually, this is a pyramid. If I talk about the surface area of a pyramid, that is the base area plus sum of areas of all the faces. Now, a scenario could be like this, in which all these four areas have the same dimension. So therefore, it would be 4 times this. So over here, surface area is the base area plus 4 times area of any one face. But over here, this is technically surface area is base area plus sum of all faces. This is also the sum of all faces, but since it has equal sides, the 4 faces have the same dimension. What about the volume of the prism? I'm saying prism twice because that is something in my head. When we talk about volume of pyramid, that is 1/3 multiplying with base area multiplying with the perpendicular height. Now, if you recall, why am I deliberately calling it a prism? That is, when we talk about volume of a, a prism, that is cross-sectional area multiplied with height. When we talk about volume of a cone, that is 1/3 into base area into height. So now, if I talk about a pyramid, so a pyramid is very closely related to a cone. 1/3 is over here, 1/3 is over here. So basically, I wanted to relate a cone with a pyramid. Base area is there, base area is there. And perpendicular height is there, perpendicular height is there. So let me write perpendicular over here. Now, let's apply our knowledge to this particular diagram. What we see over here, first of all, let me choose the same color. That is a green color for the height. And I forgot to choose this for the straight line. That goes like this. And a purple color for this thing. And then there is a red color, but this time instead of red, let me use blue. So this is going all the way like this. Now this is the right angle triangle that we are focusing on. And yes, the slant heights are there. Let me mark them with orange. So if I look at the slant height and let me increase the thickness. So the slant height is this one that goes like this. And then there is this one that goes like this. And then there is this one, something like this. And yes, there is the base area which I am labeling in blue. So this is blue and this is blue. And yes, this is drawn dotted, and yes, there is another one dotted. So that's how the figure is completed. And let me again use orange color because I want to label this thing also. So now this is a 3D diagram, and I'm interested in this 4 centimeter. The base is 3 centimeter because this whole thing is 6 centimeter. This is 6 centimeter. It has got a square base. So therefore, this purple one is 3 centimeter and this is 5, and that exactly fulfills the criteria. 5 square is 4 square plus 3 square. Yes, it fulfills Pythagoras theorem. Now, if I am interested in the surface area of this pyramid, that is the area of the base. So let me choose a thicker marker. So this is pyramid. That is the base area plus 4 times area of the lateral surface. That is all the faces. So therefore, what is the base area? That is 6 by 6, and area of any one of the surface. Now, how can I calculate that? I can calculate that because if this is 5 centimeter and this is 6 centimeter, so it will be divided into 3 centimeter and 3 centimeter. Therefore, this orange line, this is also 4 centimeter. So the orange line over here, this is also 4 centimeter according to the same Pythagoras theorem. So therefore, the base is 6 and this thing is 5. Actually, I don't need the 4. So there is no need as such. So let me just erase this. So this is not needed. So what we do is that this is 6, this is 5, this is 5. Actually, this 4, this is the 5 one that is needed. So therefore, this is half and this is base is 6, height is 5, and there are 4 such faces. So let's multiply it with 4. So therefore, use a calculator or just basic maths. 36, 2 into 4, that's 2, division. And 6 5s are 30, 30 into 2 is 60. Therefore, this comes out to be 96 centimeters square. That is the surface area of the pyramid. So this thing is done. What about the volume of this pyramid? That is 1/3 base area multiplied with perpendicular height. What is the base area? The base area was just calculated. That is 6 by 6, which is 36. So this is 1/3 into 36 into the perpendicular height, that is 4 over here. So let me write 4 over here. So therefore, 12 into 4, which comes out to be 48 centimeter cube. That is the volume of this pyramid. So this basic calculation is done. Now, some other pieces of information that I've listed over here. That is, a triangular pyramid has a triangular base. There are 4 faces, the 3 lateral face and the base. There are 4 vertices, 1, 2, 3, 4, and there are 6 edges. These are the edges, 1, 2, 3, 4, 5, and the downward one, that is 6, and further information is given over here. Now let's try out some questions from the paper 1 exercise. Now the question says, ABCDE is a pyramid. So this is A, and this is B and C and D and E. It's a pyramid. Let me underline few things. Let me just make it thinner. The base is a square of side 10 centimeter. So this is 10 over here, and then this is 10. Let me label all the sides. Of course, it's not necessary to do in the exam. I'm just doing it right now for you to understand it thoroughly. The sloping faces are isosceles triangle. AB, AC, AD, AE is 13. So this is AB and this is AC. And what else is there? There is AD. This is also sloping face like this. And then there is a sloping face that goes like this. Of course, it's a 3D figure, so it won't give you that feel that they are equal. Calculate the area of the sloping face ABC. Now, first of all, let me choose a green color. And let me draw a line like this. Now, once I have drawn this line, what I'm doing is that let me label it in such a manner that these two sides are equal. This 13 and this 13 are equal. This is perpendicular. I've drawn a perpendicular on the lateral surface, and this becomes 5 and this becomes 5. That means this green thing over here, this is the height, the slant height you can say. So let me write this thing as L. So therefore 13 square is equals to, that is 5 square plus L square. This is 169, this is 25, this is L square, 144 is L square, therefore L comes out to be 12. Now there are some famous triangles in trigonometry, do remember them. So let me draw a line over here, something in blue color, and I'm just labeling few famous right angle triangles that you will come across in life. The first one is 5, and actually let me write it like this: a 3, a 4 and a 5. Double of that is 6 and 8 and 10. And then the next important one is 5, 12 and 13. As soon as I pointed out 13 and 5, I knew that this length would be 12. It's just a formality that I have to do the calculation, but I have to do it. So L is equals to 12. So area of the sloping face ABC. So this is A, this is B, this is C. The base is 10 and the height is 12. You cannot use 13. So therefore, area of the sloping face. So area of sloping face, that is ABC, that is half into 10 into 12, that comes out to be 60 centimeter square. What else are they asking? Now what are they doing? They are taking this pyramid ABCDE is joined to an identical pyramid BCDEF. So BCDE is already there, and then there is F downstairs. So basically identical pyramid is joined. Calculate the surface area of the solid ABCDEF. Now this is a trick question. So in B part 1, there are 4 faces of A, B, C, D, E. That is this. It's the same triangle as before. This is 1, this is 2, this is 3, this is 4. And yes, there is a base. So let me just write 4 sloping faces. And when we talk about the other one, that is B, C, D, E, F. So 4 sloping faces for the same, which is B, C, D, E, F. When these two are joined, what is ignored? That is this thing, because it's no more a face. And this is like this figure. So there are 2 faces, and there are 2 faces, and there are 2 faces, and there are 2 faces. So there are 8 faces altogether. So the surface area is how much? That is 8 multiplying with area of one face, which is 60. That is 480 centimeters square. And then the second part, that is about locus. Describe fully the locus of all points which are equidistant from A and F. So equidistant from A and F, that will be like a perpendicular bisector but in 3 dimension. That will be this face, this square face, that will be the locus, but that is not our point of concern over here. Okay, that is the plane BCDE. BCDE, this surface is called a plane. Now let's do some paper 2 question, and this involves trigonometry. So let me grab my calculator, get it ready, make sure it's in the calculator mode and it's in the arithmetic mode. Okay, I think I just need to menu and 1. Okay, now it's all good. Now, first of all, the question says, in the triangle WXY, WXY, WX is 24. So let me just label it. So therefore, this is WX is 24. And then WY is 17. So WY is 17. And then the third one is I'm labeling it in green like this, and the angle is given. First of all, they are interested in finding the area of triangle WXY, and they are interested in finding the green length, which is XY. So first of all, 1 part A, the formula is area of triangle. Since it's a non-right angle triangle, half AB sine C. What is A and what is B? Two sides, and C is the included angle. So we have two sides, this, and therefore 55 degree is the included angle. So therefore the area equals to half into 24 into 17 into sine of 55 degrees. Now first of all, I'm calculating sine of 55. I'm multiplying it with half, and then I'm further multiplying it with 24 and 17. So this answer is coming out to be 167.107. And I'll write this thing as 167 centimeter square, correct to three significant figures. What about XY? What is XY? XY is based upon cosine rule, will be calculated based upon the concept of cosine rule. So let me write XY, the whole thing square, that equals to 24 square plus 17 square minus 2 into 24 into 17 into cosine of 55 degrees. Now first of all, 24 square, I think it's 576, and 17 square is how much? 289. So let me first write this down. And then what is inside the bracket? So again, let me use cosine of 55 degrees. So cosine of 55, and I'm multiplying it with 17 into 2 into 24. This is coming out to be 468.038. 468.038. Naturally, I have to use the calculator. So this is 576 plus 289 minus 468.038, and this is coming out to be 396.962. So let me write it properly. This is XY, the whole thing square. Therefore, XY is square root of this answer, and this is 19.923. So this, I'll write this thing as XY is 19.9, correct to three significant figures. We have to take care of the accuracy. Now, what else is there? Now the question says that the volume of a pyramid is this much. That means they usually have a habit of writing this thing down. The triangle WXY shown in diagram 1 forms the horizontal base of the triangular pyramid. So we had WX, WY and XY. So we have WX, let me label it in the same manner, WX and WY, and the third one was XY. So I'm using the same color as before. This forms the base, and the perpendicular height, I'm labeling it in purple color, that's the perpendicular height. Now it's a pyramid. The vertex is vertically above Z on WX. So Z is on this line WX. WV is 15 centimeter. That is the height. WZ is 1/4 of WX. Now how much is WX? WX is 24. So let me write this thing over here, something very basic. WZ is 1/4 of WX, which is 24, which comes out to be 6 centimeter. This is WZ. Calculate VZ. Now, if I want to calculate VZ, so let me just label this thing, hold for a second. So let me choose the color. This is VZ, that is the height. Now the height is not 15, my bad. So height is not 15. Let me draw it like this. This is VZ and VW is 15. So let me label this thing in orange color. So this thing is 15 like this. And what else is there? And then we have WZ. Let me use red color for this one. Okay, now I can label it properly. This thing is 15. This thing is W. This is Z. This is 90. This is V. And WZ is 6. So therefore 15 square is equals to 6 square plus VZ square. This is 225. This is 36. This is VZ square. So therefore 225 minus 36, I'm getting 189. I'm taking the square root and it's coming out to be 3 root 21. So VZ square is 189. Therefore VZ is square root of 189. Let me convert it in decimals. So where is that button? Yeah. So the button is over here. VZ is 13.7477. Therefore VZ is 13.7 centimeters, correct to 3 significant figures. Now this thing is done. This is part A. Hence find the volume of the pyramid. So volume of pyramid, part B, that is 1/3 base area, which we have calculated before, multiplied with height. Now remember, the height is VZ. This VZ is the height. We will use unrounded value. So we will use unrounded value. Yes, not so much, but 1, 2, 3, 4. 4 significant figure is perfect. So this is 13.75. This is the 4 significant figure rounded value that we will use. The unrounded value is there, but since this is 7, so therefore I round it off. So now what is the base area? Base area is over here, which is this. Again, we will use the unrounded value, which is 167.107. So this is 167.107. Don't forget this 1/3 over here. Don't forget that you have to use the calculator. So therefore 167.107, I'm multiplying it with 13.75. I'm further multiplying it with 1/3. So I'm writing a fraction. This is 1 at the top and 3 at the bottom, or I could have divided by 3. And this comes out to be 765.907. And since this is the 4th significant figure, therefore the volume is 766 centimeter cube. This answer is given correct to 3 SF. So that is, let me just double check the answer. This is question number 1. And this was one of the answers. And then we had this thing, and then we had this, and this is 766. So that's all good. Now, let me show you the working for this question. Now the question says, in diagram 1, ABC is an equilateral triangle of side 8 centimeter. So we have A, B, and C. That's an equilateral triangle. D and E are the midpoints of AC and BC respectively. And D and E are the midpoints. BD and AE intersect at F. There is F over here. Find the area of the triangle ABC. That I'll do in a short while. Now, first of all, let me just highlight the 3 sides over here. This is 1, 2, and 3. And what else is there? Let me label this thing in blue. Let me label this thing in green like this. And let me think of everything related with angles. Now, first of all, let me label this thing as 60 degrees because it's an equilateral triangle. This is also 60 degrees over here. And then this is 60 degrees over here. Now, over here, the small one is 30 degrees. It's half of that. Why? Because this perpendicular will divide it equally. This one is 90 degrees. Or I could have said that since this is 60, let me just highlight this. This is 60. This is 90. Therefore, this is 30. Now we are interested in, first of all, I'm focusing on this. AFB is 120. So that's A, this is F, and this is B, this is 120. Now what else can I apply? I can apply this idea that this is 30. Therefore, this is also 30. The same goes over here. This is 30. Therefore, this is 30. And therefore, these two sides are equal. So now if this is 30, if this is 30, therefore this has to be 120 because the sum of the angle is in a triangle is 180 degrees. So 30 and 30 is 60. 180 minus 60 is 120. I have proven this point. The answer is that we can say sum of angles in a triangle adds up to 180 degrees. And before that, I can say even before that, focus on the triangle that is AFB. There are two angles of 30 degrees each. Therefore, AFB is 120 degrees. Now, what about the area of the triangle ABC? For area of the triangle, what I can do is that I can say this is half into 8 into 8 into sine of 60 degrees. I'm using the concept area of triangle, that's half AB sine of C. So therefore, this is 64 divided by 2, that is 32. Sine of 60 is 0.8660. So let me multiply this out. There are some values which are very easy to remember. So this comes out to be 27.712. This is 27.712, again rounded off, 27.7 centimeters square. So this is the answer for this part. So part 1 is done, part 2 is done, part A is done. Calculate AF. No, AF is left. What is AF? So A till F is this much. That is A till F. And BF will exactly be the same. Now we have 8 in front of 120. We have 30 in front of AF. So basically I'll use sine rule. So if I use sine rule, I'll write AF and 30 degrees. So AF divided by sine of 30 degrees. That is the same thing as how much? 8 divided by sine of 120. So that is 8 divided by sine of 120. Let's first make AF the subject, then I'll use the calculator. 8 sine 30 divided by sine 120. So that is 8 into half divided by sine of 120. That's the same thing as sine of 60, 0.8660. That is 4 divided by 0.8660. So let me divide 4 divided by 0.8660. This comes out to be 4.6189. 4.6189, which is 4.62, correct to 3 significant figures. Don't forget to write the units. That is AF. Now let's double check whatever we have done so far. We have calculated AF and we have calculated area, 27.7 and 4.62. So this is 27.7 and 4.62, and this is convincing explanation which we already did. Now let's focus on this. Again, we have the area formula. The volume of pyramid is 1/3 base area multiplied with height. This is for multiplication. It's not crossing it out. This is for multiplication. Now it says the equilateral triangle of side 8 centimeter in diagram 1 forms the base of the triangular pyramid. So this one over here, that's the base. We already have the area. We have AF also. So remember, we have AF also. And then it says the vertex V is vertically above F. So V is vertically above F right over here. Now it says the other dimensions are given. This is 8. AF is known. We just calculated it. Calculate the surface area of the pyramid. And what else is there? And then it says VABC in diagram 2. Now we have how much? We have AC. Now let me first label it. We have AC as 8, we have this thing as 8, we have BC as 8. So let me first label it. So let me choose a red color. AC is 8, BC is 8, AB is 8. That is the original triangle. And then we have this side as 8 over here. Now, if this is 8, naturally, this will also become 8. And therefore, this will also become 8. So, all the four sides have the same dimension, the three sloping faces and the base. So, surface area of the pyramid, that is basically 4 times area of triangle. Which triangle? That is the triangle ABC. So we have 27.712 into 4. So let me multiply it out. 27.712 into 4. So this is 4 times. Okay, just hold for a second. That is 4 times 27.712. That comes out to be 110.848. That comes out to be 111 centimeters square. Calculate the volume of the pyramid. Volume of the pyramid is 1/3 base area, which is 27.712 into height. Now, what is the height that I'm looking for? Let me highlight this. Now, first of all, let me draw it like this. And then I have AF over here. So AF was calculated. There it is, 4.62 or 4.6189. So let me draw it like this. Let me draw the purple thing over here and then this blue thing over here. So we have this thing as 8. This is V. This is F. This is A. This is how much? 4.6189. This is 4.6189. And I'm interested in finding the perpendicular height. So 8 square is 4.6189 square plus h square. Therefore 64 and 4.6189 square, that is 21.334. 21.334 plus h square. H square is minus 64. That is 42.66576. Let's multiply it with -1 and then let me take the square root of the answer. So this is h is 6.53. This is the working for part 2. Okay, so h is 6.531. So this is 531 and let me highlight this. Okay, highlight it, not cancel it. So this is centimeters. Therefore, let me use this 6.531. So 6.531 into 27.712 divided by 3. This comes out to be 60.33. This is 60.33. So I'm writing this thing as 60.3, correct to 3 significant figures. This is also done. Now let me check these two answers, 111 and 60.3. So this is 111, this is 60.3. All good, all perfect. Now it says, this is something to do with similarity. A pyramid P is geometrically similar to VABC and its volume is 1/64 of the volume of VABC. Now let me call this thing as Q for simplicity. What it's saying is that VP is to VQ. Its volume is 1/64. So this is 1:64. I can write it like this. I can even write this thing as VP is 1/64 VQ. Now it says find the length of an edge of P. Now, do we have the length of an edge of this triangle? Yes, we have, which is 8. Okay, that's right over here. This is 8 we have. So therefore, what I can do is that I can write this thing as the ratio of length of P to length of Q, the whole thing Q. So let me compare these two. That's the relationship. So LP is to LQ is 1/64 cube root. That comes out to be 1/4. LP is LP, LP is actually the unknown one, and Q is 8. So therefore LP is 1/4 of 8, which comes out to be 2 centimeters. There is no accuracy issue. I don't know why the examiner has written plus minus 0.001. Excuse me. There is no need as such. I don't know, maybe they have done some calculation or something. This is purely based upon area and volume of similar figures. So when we talk about similar figures, the ratio of volume is the ratio of length cube. Ratio of length is cube root ratio of volume. And that is the ratio that we get. We just take this 8, take to the other side, and we find the length of P. Now it says, a pyramid that is identical to P is removed from each of the 4 vertices of VABC. Now we are removing a pyramid from the corner. State the number of faces of the new solids. So now when we remove a pyramid from one of the face, what happens is that we are creating, there are already 4 faces. Now we are creating a new face at each edge. The number of faces of the new solid. So there were 4 old faces. So part 2, there were 4 old faces, 4 new cut out faces, not phases. That adds up to 8 faces, that is for the new solid. That completes our lecture on pyramids, which was about surface area, which was about volume, and more than that, it was about Pythagoras' theorem.